Okay, so again, as mentioned a while ago, the second statement construct is the selection. It evaluates one or more alternative, no? So when you say selection, you are already testing a condition. We call it also conditional program statement, no? So in this case, in C++, we use the if-else statement and the switch case statement to perform and evaluate one or more alternatives. So you know already how to perform selection. Then another is the looping statement. So looping statement is also the same as selection, but in this case, we iterate a block of codes. So we test a condition. When that condition is true, we all again continue to perform. If that is a flowchart, we always perform. If the statement is true, we always perform the flow on top of the flowchart. Now, when we define data structure, all those actually topics, we are going to discuss it here again in data structure. So if I were you, please take note and please be reminded that you need to review all about C++, specifically the 127 part. So we're going to discuss here and we're going to use here topics array, pointers, link structures specifically. That's why we call it data structure. So take note of that, class. Now, when we define a data structure is a way of organizing the data considering not only the items stored, but also the relationship from each other. Okay? So it is also an aggregation of atomic and composite data types. So later on, we're going to define and differentiate what is a atomic data type and what is a composite data type. Okay? A data structure also is a combination of elements of which is either a data type or another data structure. So this is just like a data structure is actually compared to an array, but array is not similar to data structure. So what are the similarities of data structure and an array? Okay, so when we say array is actually composed of elements. So the same thing as data structure, but array composed of homogeneous elements. So when we say homogeneous elements, if you declare the array as integer type, the integer type, the rest of the elements within that particular array is a whole number or an integral type of value. While data structure is not homogeneous, meaning you declare different types of data types within the structure. It's like one string or one integer or one double type. Okay, so that's data structure. And of course, a data structure and an array is a group of data elements grouped together under one name. Okay, so as mentioned a while ago, so we're going to define and differentiate the atomic data type and the composite data type. So when you say atomic data type, this data type are data that we choose to consider as a single non-decomposable entity. So when you say non-decomposable entity, you can actually break down the value. So like for example, when you declare it as 132, 52,000.37, okay, or C, or character C, so that's atomic. Okay, that's considered already as a single entity. But when you say composite data, what are those variables that can be broken down into pieces or subfields? Okay, so for example, your name, you have what? A full name. That's actually, when you say full name, it's atomic. But when you say surname, first name, middle name, you can actually consider it as composite data type. So specifically, another example is the telephone number. So telephone number are composed of area code, country code, and telephone number. Okay, so we all know already what is a data type. A data type is a set of data and the operations that can be performed on the data. And then structure means a set of rules that holds together the data. So in data structure, we're going to discuss all about the sets, arrays, lists, queues, and stacks. We have also trees, okay, and then we have also graphs and networks, and of course, sorting techniques in data structure. So these are just some data structure that support a list. So we call it a matrix. It's just like a two-dimensional array in C++, a linked list, okay? So if you're going to take a look at a linked list is just like an array also, a one-dimensional array. But the process of a linked list is different from array. Then we have also called a tree and a network or a graph. Now, if we are performing process within data structure, we need to use the abstract data type. What is an abstract data type? It is a mathematical model for data types. It is also a class of object whose logical behavior is defined by a set of values and a set of operation. So let's say, for example, I have this particular record, and I'm going to, for example, in a school, we have what we call the student information system. Then we want to add another student, or we want to delete another student. So what are we going to do is we need to perform this type of abstract data type code to perform that deletion, that if we want to display, for example, from the last student up to down to the first student, or vice versa. And for example, if you want to search that particular student in that particular structure, so we need to use this type of abstract data type. So again, another definition of an ADT or abstract data type is a data declaration packaged together with the operations that are meaningful for the data type. That operation is, as I mentioned a while ago, for example, I want to include this student in the list, so I need to add it. Okay, so how are we going to add that particular student in a structure? Then we use the abstract data type. Okay, now this is an example of an abstract data type model. So if you're going to take a look at this one, this is like a program. Okay, so this is function A, function B, and a private function. So if you're going to take a look at here on function A accept data input. Then once, for example, that student has been inputted, what are we going to do? We need to put it in the data structure. But how are we going to put it in a data structure? We need to use the ADT code, or the abstract data type code. So for example, I want to add it. So what type of ADT we're going to make use of, or what process we're going to make use of to include it in the data structure. Then for example, in function B, it accepts data and also outputs the data within the data structure. So again, we need the ADT code to display or output the data within the data structure, and same thing as inputting the data and putting the data within the data structure. Now, to do that, we need to use pointer, okay? And for the application program, and we need to use the ADT class code. So for example, this is the program, and we want to include, or we want to include the data in the data structure. So in data structure, we always use dynamic memory. Okay, so take note of that, dynamic memory. So that means we always use the word or the process new operator and delete operator. Okay, so now, for example, here, ito yung kanina, okay, we want to include that particular student. And there's already an existing data structure of the student. So if I want to include that student, I need to use an ADT class code, which is insert. Okay, insert means there's already an existing data, and I need to add this particular data again within the structure. Now, what about search? Search ADT class code means you are this is like in an array, you are searching for a value, and then it determines whether it is found or not found. Okay, so the same thing as data structure. How about traverse? Traverse means you are displaying the structure of the data from the first position down to the last position, or vice versa. Then delete and destroy is not the same thing. Delete means you are searching first for this particular data, and what do you want to do? I want to delete that, okay? So delete means deleting one data from the structure. Destroy means you are already deleting the entire data from the structure. Now, an ADT class code create means it's just an empty structure. So you need to create a structure before you insert a data. Okay, so that's actually this figures talks about, or all about. Okay, so these are examples of abstract data type. Okay, so these are the list of ADT. So this is just like a method or a function in C++. So get. Get means return an element from the list at any given position. So you can use insert, ADT. So insert means you are inserting an element at any position of the list. Anyway, when you say linked list, it's just if it's an array and we want to insert a data within the array, we cannot do that unless we add another position. But for the linked list, we can actually insert and delete any data from any given position. Remove means remove the first occurrence of any element from non-empty list. Remove at, meaning when you say at, we are removing the element at specified location for a non-empty list. Replace means replacing an element for at any position. Size is just returning the size of the list. So let's say you add already, there's an existing 5 data, and you add already 3 more data. So the size of your structure is already 8. Is empty is just testing whether your structure is empty or not. Is full means, since we're talking about dynamic allocation, if you still remember in CS 127, it discussed how we identify whether the dynamic allocation has been already full or not yet full. So we test it by a testing condition, and we use a function is full. Okay, so for example, for stack ADP or abstract data type, so we use push, pop. Push means insert, pop means deleting the data on top of the stack. Pick means we just want to know what is the value on top of the stack. Size is again returning the number of elements within the stack. Stack will be discussed, don't worry. So this is just an introduction. Is empty, you are just testing if the stack is empty or with data or without data. And is full means if the stack is already full or not. Now, these are just the coverage of what are we going to expect from data structure. So again, when we say data structure, we use a dynamic allocation. So we call it dynamic data structure. So the definition is grow and shrink during the execution. Okay. And then linked list is insertion and removals made anywhere, as mentioned a while ago. So stacks, we're going to discuss also stack. This is actually stack has a structure of LIFO. LIFO means last in, first out. So the insertion and removals made only at the top of the stack. While queue or queues, okay, structure is FIFO, F-I-F-O, meaning the insertion made at the back and removal made from the front. FIFO means first in, first out. Then one of the last topic of data structure is a binary tree. So when you say binary tree, from the word binary, there are only, for every root of the tree, it should have only either no children, 1 child, or 2 children. Okay, so this one, I'm going to stop because this one I'm going to discuss it again, and I'm going to use another